Hi everyone, this is Steve Mackay from Engineering Institute of Technology. Just want to briefly talk about diesel power generating plants, a quick introduction, take about 10 minutes and give you a bit of insight into diesel. I'm Dean of Engineering at EIT, Engineering Institute of Technology. We've got about 1,500 students currently on our advanced diploma programs from all over the world, 72 countries, and I've had a lot of experience in industrial automation and quite a bit in mechanical and electrical engineering, so that's my main area of interest. So just really want to talk about energy sources, choice between AC and DC power, single phase versus three phase, prime movers, power plant components, type of engines used, and then just a bit of an introduction to the diesel engine. So 10 to 15 minutes of your time, sit back and let's run through the key areas here without getting you bored out of your mind. Please send me any emails or any questions you have. As far as energy sources are concerned, there's conventional energy, which is what we're used to, and then, of course, non-conventional renewable energy, like wind, sun. Unfortunately, I know the greenies will shoot me down here, but very, very hard to see renewable taking over, although obviously I would prefer them, cleaner and you've got more control. Very hard for storage of power and just trying to get up that level of saving in terms of keeping the environment clean and avoiding the greenhouse effect. So it's a challenge. Just as a matter of interest, calorific values for different sources. This is unfortunately in kilocalories. It should be kilojoules. I'm sure there's a few guys here who can tell me the difference between kilocalories and kilojoules, but just to give you an idea of the value. So wood, you go from 3,500 all the way to 3 times, which is paraffin, or as Americans call it, kerosene. Charcoal's in the middle. As far as AC and DC power is concerned, most of the time we deal with AC power. Very good for long-distance transmission, although there's quite a lot of examples of very successful high-voltage DC transmission now. But the great thing about AC power, it's very easy to transform from one range of power to another. But DC is still very much in the wings, waiting to take over the world. Three-phase is generally the name of the game with most power sources. In fact, even domestic households, a lot of them, even in some countries which traditionally only use single-phase power, are installing three-phase. Very efficient, very effective. So the idea is you have a prime mover, diesel engine, rotator generator, which produces three-phase power, 3 sets of conductors. Probably you could argue that if you've got 3 phases, you often have a star connection where you'll have a central neutral. Alternator is a common term used for AC generators. The AC waveform, for some reason, hasn't come out on the slide, which is a bit odd. But as far as AC vectors are concerned, you have a sinusoidal waveform like that, and it's represented as a phasor. So it rotates that ray around. So if you're standing over here, you'll see first the A phase, B phase, and then the C phase rotating around. If it's going in counterclockwise, your motor or your generator will be operating in the reverse direction. Capacity of generator is normally kVA, 1,000 volt amps, that's a small k, and you find that useful power, kilowatts, is 0.8 times the kVA. So you've got your good old triangle power, and the useful power is the kilowatt hours, which is this little bottom part here. This part here is your kVA, and this, which we're not going to discuss here, is kVAR bars, which is reactive power. So energy capacity limits the maximum kVA, and obviously capacity of power plant is the total megawatts that you produce. And voltage is typically 25 kilovolts due to the practical limitations of the windings and the structure. Other generator components are the stator, which is where the windings carry the load current, the rotor, which is a rotating bit, and that's connected to your diesel engine or prime mover, and that converts from mechanical to electrical energy. And then, of course, you've got the exciter field, provides DC supply, the field windings that give you a rotating magnetic field cutting across the stator windings, which hopefully help you to generate the voltage. Here's an example of a large generator, very traditional one. Prime movers could be internal and external combustion. Internal combustion is diesel engines, gas turbines. Diesel engines are probably the most common, ranging from tiny to big. Gas turbines are very fast, very expensive, but very fast moving and capable of generating a lot of power. Arguably a lot more than diesel. And also, one power station I commissioned, we had the gas turbines, the 3 gas turbines, generating about 30 megawatts, I think it was, and you had a diesel engine which was there to provide the auxiliaries with power. So you power the diesel engine, and then that gets all the auxiliaries running for the gas turbines, which then leap into life, and then you close onto the grid. External combustion could be fuels burnt external to the prime movers, such as steam generators. Prime mover features is a sort of typical steam turbine. There's a whole range of steam turbine, gas recovery, gas turbines, and just gives you typical heat to power ratio. As you can see, it ranges quite significantly. Prime mover choice is related to heat to power ratio, and higher heat demand may tilt you in favor of gas turbines. So utility companies, heat requirements minimal, so you may find combined cycle plants may be preferred. And obviously diesel power plants are limited in size. Steam turbines, you have a steam boiler, and the plant may be based on coal, diesel, nuclear. Obviously nuclear is restricted to certain countries. Gas turbines, hot gases turn the turbine blades. You can go up to standalone capacity of 250 megawatts. Space requirements are low, but highly capital intensive, quite an expensive bit of hardware. Very high RPM. You can hear the shriek of the gas turbine, and generator coupled using a reduction gearbox. Typical gas turbine. Turbine here, gearbox, and then your generator. So gear down here. Combined cycle plants are quite interesting. They've been used quite extensively. Alcoa, for example, would have a combined cycle plant from the steam plant. From their process, hot gas is used to produce steam for running with steam turbines, and steam generator named as the heat recovery steam generator. So cogeneration plants similar, but use the recovered steam directly for process needs. You can use the steam for other purposes. Here's a typical example of a combined cycle plant. Reciprocating engines, which is where we talk about diesel engines, spark ignition, compression ignition and spark ignition. Diesel power plants use compressor air to ignite the fuel, which is sustained unless interrupted, so once you get going. And if you have planned maintenance, you can get 90-95% availability. Very reliable. A friend of mine calls one of his partners the diesel of the business. He just keeps chugging on. So very reliable and pretty proven. Power plant components are the prime mover, the generator, fuel storage and handling system, cooling system, exhaust system, and substation and control. And the types of power plant are turbines, steam turbines, all the way through to wind turbines and heavy fuel engines. So it's quite a wide range. Coal-based plants is a typical example of the advantages, economical, but very bad for the atmosphere. Natural gas, lower capital cost, not economical for smaller sizes. Quite an investment in high capital. Oil-based power plants, lower cost, compact. The problem is you could run out of oil, and not very attractive because of environmental pollution. And you also get perhaps some problems with oil with a high sulfur content, giving a bit of a polluting effect. Diesel power plants, small in size, low cost, portable, very quick to install, very proven technology. Plug and play. Major noise and carbon dioxide producers. They make quite a bit of noise, although you can suppress a lot of the noise, and it could be a fuel limitation. So power plants are the other ones. Not going to worry about that here. Diesel engines, spark ignition, compressor ignition. Spark ignition, natural gas-based, lean burn, rich burn, two types. Lean burn preferred because of the greater fuel efficiency. Engine components typically are the drive chain, which is your pistons and rods, the valve chain, the good old camshaft, valves, governor, speed control is very important, often connected up to your PLC, programmable logic controller, turbocharger to compress the intake air for better combustion, and the aftercooler to reduce the output air temperature. This actually can be one of the issues you have to obviously watch out. If you've got a very high temperature environment, you obviously need to derate the engine. So the diesel power plant also has support systems such as generator, fuel system, all the way through to the control instrumentation and exhaust and ventilation systems. Typical operation procedures. It's a lube oil system startup, ensure proper pressure. Then you start without any load, of course. Otherwise you won't be able to get going. Bring up to full speed, start applying load slowly, and ensure that you've got a minimum loading of about 50% to prevent any maintenance issues, carbon formation in the engine. And idle run recommended before shutdown. So in other words, you take the load off and you run it for a while before you shut it down. So pretty established procedure. We had one embarrassing situation where I was a consultant to a job where the software hadn't been set up correctly. I didn't write the software, I hastened to add. And I wanted to test it beforehand, and of course the emergency generator diesel system, Caterpillar, was put straight onto the grid. Needless to say, you hear the sound of brrr and then crash, stop. So obviously you need to start with any load on the alternator. Advantages are fast installation time, quick startup, you can follow the load with governor control, part load efficiencies, pretty reliable. Maintenance is pretty proven, straightforward, because it's lower capital cost. Although you could argue that the cost per kilowatt will be obviously a lot better for larger installations than just diesel, but it's pretty reliable. And a lot of very inventive people that have tried different fuels for diesel, including biofuel. So that's it from me, Steve Mackay. This is just a quick review of what we've discussed, but any questions, please drop them over to me, Steve Mackay. I'll be delighted to answer them. Thank you very much for listening in. Sorry it took a bit longer than I thought, but thank you very much. Steve Mackay from Engineering Institute of Technology signing off at this point. Bye.